Okay, so we're continuing along in 3.1. We've got a few rules here. So let's just go ahead and maybe do an example of using these rules, and then we'll get some more rules. So suppose f of x equals x plus x squared minus 4. Let's compute f prime of x. Now we're going to be using our rules. And so we see x to the 1 power will be 1 times x to the 1 minus 1 is 0, right? Plus 2 times x to the 2 minus 1, and then plus 0. Okay, so let's, if we simplify that, that looks like it's going to be 1 plus 2x. Good, and so there's our derivative. Easy. Good, so let's do a couple more of these. By the way, you might notice that this rule here for the sum would have looked exactly the same had we had a minus sign here. Let me get a different color for that. If we had a minus sign there, minus sign there, minus sign there, right, that would have given us a minus sign where? Here, I believe, right? Wait a minute. Did I get my minus? Oops. Oh no, my proof on the other page should have had a minus sign right there. Did I have a plus sign there? I don't want to go back now. See if you can prove that. That should have had a minus sign there. Ooh. Ooh. Okay, so now we've got all kinds of minus signs. But we need a minus sign there for if we have a minus sign here. And then that'll give us a minus sign there. And so on. So that'll end up with a minus sign. And so the idea here is that if this had been a minus, then this would be a minus. Okay, and so that kind of brings up the next question. What happens if I have a constant times the function? Well, in that case, we have limit as h goes to 0 of c times f of x plus h minus c times f of x divided by h. And notice that you could just factor the c out. And in fact, if the limit exists, we can go ahead and factor the c all the way out. So we end up with the derivative being c times f prime of x. Good. And so now, for example, if I wanted to take f of x equals 5x cubed, right, then f prime of x, using our formula, would be 5, that's my constant, and now I take the derivative of x cubed, but bring the 3 down, x 3 minus 1 on the top, right? So that becomes 15 times x squared. Good. All right. And one other formula that they have in section 3.1, and that is the exponentials. And so we won't spend a lot of time on the exponentials, but we could say that if I suppose my f of x is equal to a to the x power, we saw in the exercises that f prime of x is equal to the limit as h goes to 0 of a to the x plus h minus a to the x over h. And so remember what we did? We factored out the a to the x, and then we ended up, let's go ahead and factor it all the way out since it doesn't depend on h. Then we would have a to the h minus 1 divided by h. Notice that that 1 is actually a, you could write it as a to the 0 power, right? And so this is the derivative of a to the x evaluated at 0, right? And so the derivative of a to the x is going to be a to the x times the derivative of a to the x at 0. And so kind of the trick here is that we're going to define e, definition. E is the number so that a 1 is equal to the limit as h goes to 0 of a to the h minus a to the 0 over h. And that's a really weird way of defining it, right? Is the number a such that this is true? Okay, but it does work out that you can define e to be this, and so therefore by definition what we're saying is by definition then if f of x is equal to e to the x, then the derivative is e to the x times 1, which is e to the x. And so e to the x power is a function whose derivative is equal to itself. The derivative of e to the x is e to the x. Good. And now you might ask what the general derivative is, and it is. Let's go ahead and write it, and then we'll prove it later. Just to finish off the table. To finish the table, if f of x equals a to the x, then f prime of x is equal to a to the x times, remember it's the derivative of a to the x evaluated at 0, and it turns out that that number is the natural log of a. And again, we won't prove that right now, we will prove it later. Good. And so now let's go back to our table of functions that we now know the derivative for. So that's going to be, in terms of specific functions, constant, x to the n, e to the x, and a to the x, right? And then for functions, we have c times f, and then f plus or minus g. So for x to the n, we had n x to the n minus 1. E to the x is e to the x. A to the x is a to the x natural log a. C times f is cf prime, and then f prime plus or minus g prime. Good. And so we're going to be using this table now. You know, if this is your first time through calculus, or it's been a long time since you've seen calculus before, I would recommend go ahead and to make flashcards for each of these, because we want to memorize this table. Okay. Maybe we can try a few. So how about let's see. How about if s of t is equal to the fourth root of t minus 4e to the t, find the velocity and the acceleration. All right, so velocity is going to be the derivative of the position function, the s of t. And so in this case, you might write that as t to the 1/4 power, right? And so when we come to take the derivative, we'll have 1/4 t to the 1/4 minus 1. And then this is a constant times e to the t, so that's going to be minus 4 times e to the t again. So just to simplify that, 1/4 times t to the minus 3/4 minus 4e to the t. So that is the velocity function. And now for the acceleration, we take the derivative again, v prime of t, which is s double prime of t. And so in that case, you notice that you're going to have 1/4 times minus 3/4 times t, and then it's going to be minus 3/4 minus 1. And then the minus 4e to the t just comes along for the ride, right? Good. So that's going to be minus 3/16 t to the minus 7/4. Is that right? Minus 4e to the t. Good. So there's your acceleration at time t. There's your velocity at time t. Good. Example. Find the equation of the tangent line to y equals x minus the square root of x at x equals 1. Okay, so for the line, we need a point. Oops. We need a slope. Well, maybe I'll put point first and then slope. So for the point, we want to evaluate our function at 1. That would be 1 minus 1, which is 0. So the line goes through the point 1, 0. And the slope is the derivative evaluated at 1. And so in this case, it's going to be 1 times x to the 1 minus 1, right? Minus 1/2 times x to the 1/2 minus 1. And then we're going to evaluate that at x equals 1. This is known as an evaluation bar here. And so it's kind of handy when you're computing something but you want to evaluate it at a point. So this should just give us a 1, and then this will give us a minus 1/2 x to the minus 1/2, evaluated at x equals 1. Looks like 1 minus 1/2, which would be 1/2. Good. That's not too exciting. Oh well. Y minus 0 equals 1/2 times x minus 1 is the equation of the tangent line. Good. So we're out of time there. Maybe we'll try a few more homework problems in the next video. See you then.